periodic table, the leftmost element is nitrogen. So look on your periodic table, they should be sitting right next to each other. And the leftmost one will be 12. So if we have X amount, it's just 12 times X from maths. The molar mass of hydrogen is 1, if you look on your periodic table. And then so we multiply by how many hydrogens we have, which is 2. Write out the molecular formula for aluminium hydroxide. And remember, we need to know the valency of these chemicals. So aluminium has a valency of +3. OH has a valency of -1. Therefore, in order to achieve neutral chemical, we need 3 OH ions for every 1 aluminium ion. And so we get AlOH3. And the name would be aluminium hydroxide. We don't say trihydroxide because there's really only one way that we can form this. So we don't need to specify anymore. Okay, what about naming this compound? So it's composed of N and O. Now, if you look on your periodic table, the leftmost element is nitrogen. So look on your periodic table, they should be sitting right next to each other. And the leftmost one will be nitrogen. And so there are 2 of these nitrogens, right? There's 2. We say dinitrogen. Di is the prefix we use for 2. So we've got dinitrogen here. Oxygen becomes oxide because it's more to the right. So we drop the second syllable and we add "ide," and there are 4 of them. And if you look up the IUPAC naming, 4, it's tetra. So it's tetraoxide. Okay, so we've got tetraoxide here. And if we put them together, you've got dinitrogen tetraoxide. Dinitrogen, there's 2. Tetra, there's 4. And you can see where the rest comes from. So what is the difference between an empirical and molecular formula? And give one example of when they can produce different formula for the same compound. An empirical formula gives you the simplest ratio of chemicals within a compound. So the simplest, the lowest numbers still maintain the ratio of elements. A molecular formula gives you the exact number of each element within a compound. If there's 2 carbons, it'll say there are 2 carbons. So ethene has the molecular formula C2H4. That's the molecular formula. However, the empirical formula would simply be C1H2 because you can divide each of these by 2 and get 1 and 2. So this is the simplest ratio. For every 1 carbon, there are 2 hydrogens. You can see that here. For every 1 carbon, there are 2 hydrogens. So it does present the same information, just in a different way. What would you need to know about the chemical to convert an empirical formula to a molecular formula? What do we need to know about the chemical in order to convert between empirical and molecular formulas? And all you need to know is the molar mass. On your periodic table, it has the molar masses of each of your elements. So the molar mass of the chemical is just the sum of all of its parts. So if it's CO2, it would just be the molar mass of carbon plus the molar mass of oxygen plus the molar mass of oxygen. So all you need to know about the chemical in order to change between empirical and molecular formula is the molar mass of the chemical. So a chemical has the empirical formula CH2.25. I realize that there's a decimal here. That shouldn't concern you too much. Don't worry, because it's an empirical formula. You would never see this in a molecular formula. And this thing has a molecular mass of 114 grams per mole. What is the molecular formula of this chemical? Okay, well, let's first start by noting that the molecular formula has the form XH2.5X. If we imagine this is 1, then this is 1 times 2.25. So for every 1 carbon, there are 2.25 hydrogen. But for every X carbon, there will be 2.25X hydrogens. So that's why we put X there. Now we're going to solve this equation. Now remember that the molar mass is just the sum of the individual molar masses of all of the elements. We know the molar mass of the chemical is 114, and that has to equal 12 times X, because the molar mass of a single carbon atom is 12. So if we have X amount, it's just 12 times X from maths. The molar mass of hydrogen is 1, if you look on your periodic table. And then so we multiply by how many hydrogens we have, which is 2.25X. And we get 14.25X equals 115, if you go through the maths and solve that. Then if you divide by 14.25, you get X equals 8. And 2.25X equals 18. So the final molecular formula is C8H18. This is the actual molecular formula of this chemical. That happens to be octane, the thing in your petrol, the main constituent of petrol. So that concludes today's lesson on naming compounds. So we've looked at naming conventions for different compounds, and we've looked at different classes of compounds and how we name them. So hopefully you've learned something about the naming convention, and you'll be able to utilize it when talking to your colleagues or other chemists about chemicals and chemical compounds. So look forward to seeing you at our next lesson.